Hi everyone, in this video we're going to talk about angle relationships. So we'll do several examples talking about how to identify angle relationships and then how to solve problems using angle relationships. Let's get started. Here are some vocabulary words we're going to be talking about here in a minute. These should all be in your foldable. We have adjacent angles, linear pair, supplementary angles, perpendicular lines, complementary angles, and vertical angles. Here's the actual definition of them. In a little bit, I'll show you on a picture what they look like and their relationship with each other. So if you don't have this, go ahead and pause this, write it down on your foldable, and then we'll do some examples where you can visually see what these 6 relationships look like. All right, let's identify some angle relationships. Let's start with adjacent angles. Adjacent angles are angles that share 2 things, a vertex and a side. So adjacent angles have to be right next to each other where they share one of the lines. And there's a lot of possibilities here. But let's go with this one right here. I'm going to highlight them so you can see it. Let's go with angle GKJ. We have this angle. For them to be adjacent, they have to be touching each other or right next to each other. And I'm going to use this other one here. So I can go to the left and use that angle. Those 2 angles are adjacent because they share K as a vertex and KJ as a line. They share those 2, and they're literally right next to each other. Now, HKJ and EKF are next to each other. Technically, this angle is next to all of them, right? But they're only considered adjacent if they share the vertex and a line. So they have to be touching each other. I'm going to write here the example as one of them, but there are several examples you could use. Angle HKJ. And JKG. All right, let's talk about linear pair. A linear pair is a pair of adjacent angles. So they have to be right next to each other. But more importantly, they also have to form a line. If you think about the word linear pair of angles that form a line. And there's several examples here we're going to go through. I'll go through one of them. Let's say that we have this angle, HKE. HKE is an angle. We can look at an adjacent one, like EKF. Those are adjacent because they share a vertex and a line. And if you notice, together, they form a line. Linear pairs should always add up to 180 degrees. They should always form a line, a straight line. So HKE and EKF. If you are struggling with how to name these angles, the order is very important. You need to know and make sure that the vertex of the angle, that when you're actually trying to measure, is always a 1 in the middle. It's always in the middle between the other 2 letters. Okay, so I did another video, 1.4 angle relationships, 1.4 angle measure, where you can go and you can check out how do you name angles and how do you identify them. All right, let's talk about supplementary angles. Supplementary angles are angles that add up to 180 degrees. So any 2 angles that add up to 180 degrees. They don't have to be adjacent like a linear pair, but they do have to add up to 180 degrees. So we will go with these 2. Let's say we have angle HKG and the other example could be FKG. Together, notice how they form a line as well, and they add up to 180 degrees. So here's another example. HKG sorry for my handwriting, HKG, and angle FKG. Okay, the key thing here with linear pair and supplementary angles is that together they'll always add up to 180 degrees. So the angle plus the other angle should always equal 180 degrees. And that is true for a linear pair and for supplementary angles. Those two will add up to 180. Let's talk about the other side. So here we have perpendicular lines. Perpendicular lines is when two lines intersect and they form a right angle, a 90-degree angle. And the symbol that we use for perpendicular lines is this upside down T. That means that two lines intersect and form a 90-degree angle. So here we have an example of two lines that are perpendicular. If you look at this box, we have a 90-degree angle right here, right? So I can say there's two lines that intersect and form that angle. I can say ray KF and KJ are perpendicular, and these two are rays. So KF is perpendicular to KJ. And I'll highlight these for you so you can see them. So KF and the other line, KJ, form a 90-degree angle, and you can see that right here with the box. Okay, that's what perpendicular lines mean. They meet at 90 degrees. Complementary angles is very similar. It's also dealing with 90 degrees. But here you have two angles that complement each other. Okay? Two angles that complement each other will always be right for each other. They will meet at 90 degrees. And here's an image. So an example would be like this one here, for example. We have angle JKG and FKG. Notice how together, these two angles combined, they add up to 90 degrees. They complement each other. Okay, so whenever angles are complementary to each other, together they form a 90-degree angle. And a way to say that, and I'll make an equation here in a minute, but I'm going to first name them. I have angle JKG and angle FKG. Okay, the key thing here is that they add up to 90 degrees. And I'll put this one in red. And I'll put it here on the top. When you add up the angles, they equal 90 degrees. And that is going to be true about complementary angles or even perpendicular lines. They intersect at 90. So those two are associated with 90 degrees. So complementary angles add up to 90. All right, let's erase this real quick. Let's talk about the last one, vertical angles. Vertical angles happen when two lines intersect, okay? Anytime two lines intersect, they will automatically form four angles. And I'm going to highlight these two real quick. There's a lot of lines intersecting here, a lot of rays, but lines are straight lines that intersect. So I'm going to highlight line HF and EG. Notice how KJ is a ray. The ray does not apply for the situation. Only lines that intersect will form four angles. We have an obtuse angle here, an obtuse angle here, and then two acute angles opposite of each other. Vertical angles are always opposite of each other. So here we have a scenario where you have an obtuse angle and another obtuse angle below it. Those two are congruent. They're always equal. So I can say angle EKF is congruent to HKG. Now, another example are the other ones opposite from each other. Over here, we have two acute angles that are opposite as well, and they are congruent. You can write those down as well. Once you identify the angle relationships, the next thing is to actually solve the problem. Identify the angle relationship and then solve. Let's go ahead and do some examples. Here we have two angles. As you read this problem, we're trying to find the value of y so that these two angles are complementary. So we're looking at PTQ, and QTR. Together, these angles are complementary, which means they add up to 90 degrees. So the way we set up this problem is we say 3y minus 10 plus the other angle, y, should add up to 90 degrees because they complement each other. Together, they add up to 90 degrees. And then we just solve for x, or sorry, in this case, y. Combine like terms, we have 3y plus y. I can combine these because they're like terms. I have 4y minus 10 equals 90, and solve for y. So we move the 10 to the other side. We add 10 to do the opposite. 4y equals 100. Divide both sides by 4 to get rid of the 4 since you're multiplying, and y equals 25. The biggest thing here was, can you identify the relationship and what that means? If they're complementary, they add up to 90. In this next example, you have a similar situation, but now you're dealing with vertical angles. Two angles that are vertical are always congruent or equal to each other. So in the picture I have UZV and I have XZY. These two angles, they're opposite of each other, so they're congruent. So the way I would set up this problem is saying the first angle is equal to 3x plus 6, the other angle. If you know the relationship, you know how to set them up and solve. And here we just combine like terms, we move things over. Subtract 3x on both sides. 2x minus 4 equals 6. We move the 4 to the other side. 2x equals 10. And then finally divide by 2 on both sides. Again, the big thing here is, can you set up the problem from the relationship given? The rest is an Algebra 1 review. Solve for x. On this last example, go ahead, feel free to pause it, give it a try. But here we have the vocabulary word of interest is that they're supplementary angles. So we have two angles, XZV, and VZU. Together, notice how they form a line. They're supplementary, they add up to 180. So that's how I set up my problem. If I know they're supplementary, I can add them up and set them equal to 180 degrees. That's the relationship. They're supplementary to each other. So let's combine like terms and solve. We have a 6x and 2x, that gives you 8x. Positive 3 and negative 7 is negative 4. We continue solving by moving the 4 to the other side. 8x equals 184. Divide both sides by 8 now. You get x equals 23. The biggest thing is going to come down to the angle relationships. The equation is going to be based on the vocabulary word. So if you know the vocabulary words that we started off with, then you can set up an equation to solve for x or for whatever angle you're interested in. Vocabulary is big in this topic. It's everything. You know the vocabulary word, you know the equation, you know how to solve. All right, hope this has helped. Don't forget to like and subscribe if you haven't already. And as always, we'll calculate it.